Thank you for that introduction, Randy. We certainly, that's what we're here today. We kind of want to review some lessons that we've learned from this project to share with the group. Some challenges that we faced and overcome, and maybe some details from the project if you're looking to do a similar one. Well, to get us started, as I mentioned, 6 years, we asked ourselves, as we went back through what facilitated the need of this project. What were some of the reasons why we really were looking at automated crane? Well, our hot mill production far exceeds the number of coils that our two downstream pickle lines could run, as well as some of the other storage bays further on down that process. As well as we can't run coils that are directly off the hot mill due to temperature reasons. So sometimes there would be some periods of time where these coils would sit outside. Well, coils that are stored outside have the potential of being damaged by weather conditions, changes in temperature, vehicles, mobile equipment, all these other reasons that would damage the product and even potentially cause delays. We also are looking for inside coil storage capacity. By doing this, we could reach new markets in the steel industry, as well as meet some of the customer requirements that were being asked for. As well as increased storage capacity. Looking for advanced inventory management, as well as tracking capabilities, which would help us assist in scheduling products that we run downstream. Looking for an overhead crane that was capable of unloading coils directly from the hot mill. These are hot coils. Temperatures up to 1600 degrees, with a mill pace of around 3 minutes and 30 seconds when coming off the line. Also looking for transferring coils to 2 different transfer storage areas for handling by forklifts. You can imagine a larger mill stretching down. Instead of having forklifts drive all the way around the mill, we wanted to unload it. So we have different storage areas. We have a port in our mill, so we wanted to have some coils stored on one side that would be easier to ship by port or rail, and then the other side of the mill for coil storage for additional production lines. We also want to be able to optimize the storage. We wanted to be able to fit as many coils as possible inside the existing building and a new extension that was to be built. We also talked about transferring coils to a pickle line 2 by transfer car. This was a new process as part of this project. We had a transfer car capable of handling 6 coils. And so the crane also needed to be able to load this for delivery to the pickle 2 line. With all this comes safety. So we're looking at ground-based safety systems, keeping people and equipment out while the automated crane ran in different zones. The coil cell design is capable of handling the entire spectrum of coils, from wide coils, narrow coils, thick gauge, thin gauge. So we needed to handle all these in our point yard. And then, as I mentioned before, we built a whole new extension as part of this project, almost 600-foot extension, to handle the storage that is inside coils. So not only did this coil allow me to be able to have storage in the existing part of the plant, but then the new as well. And then we wanted to integrate it with our existing level 2 system, and we wanted to do this wirelessly between the ground-based system and the coil yard management system, which was another task.
So with that said, we're going to talk a little bit about the detailed breakdown of all this different equipment. That would kind of give you a good history of how this whole thing came about and why we are where we are. The first obvious thing that's necessary was the overhead crane, fully autonomous, 50-ton, a double box girder design, double A4 trolley, double A4 bridge drive, single A1 trolley drive. And this is a stiff mast crane, so that way we don't have to deal with all the swaying and all that stuff that comes around with fast movements as we get to 111-foot span on this thing, 650 feet a minute bridge travel, 250 feet per minute trolley travel, and 70 feet per minute on the hoist travel. Once again, it handles coils up to 1600 degrees Fahrenheit directly off the hot mill. In an ambient We supplied a Siemens S7 PLC platform with a full safety integrated sequential step programming in order to do all the transport order processing, TCP/IP messaging from the PLC to the Coil yard management system that we put in place. Handles things such as transport orders, the crane and ground safety zone statuses. We also have interface to the ground-based safety system for zone control to allow people and personnel or maintenance equipment into certain areas. And the crane has to be locked out for certain situations like that. It also provides zone status to the Coil yard management system for forward-looking transport order processing. That way the system knows if the zone is locked out, it won't give the crane an order to go there. We also supplied with that Siemens S120 drive platform with full regen capability. Along with that, safety integrated functionality, which includes safe stop and safe torque valve functions. The EV pause for motion control with force feedback and all the devices that we're going to do next. Time of flight lasers for both bridge and trolley positioning that gave us an accuracy down to 1 millimeter. Linear encoder-based voice positioning system. Absolute rotary encoders for both the grab, rotate, and the open and close positioning. And finally, a trophy bus enabled radio for angle moves whenever the signals are run by personnel. We have a fully automated below-the-hook coil ground, custom designed for this application, designed for PTH1 standards, fully boss construction, bracket pinion leg drive system. It was capable of 210 degrees of rotation. Arm plates, toe strikers, bottom flappers, as well as temperature feedback that helped process all this data and also coil presence. We also had closely positioning on it with both incremental encoders as well as absolute encoder feedback and homing process.
So we're talking about the ground-based safety portion of this project. You see from this picture, this is actually one long bay, couldn't fit it all on just the one slide, so we kind of broke it up in half here. We have multiple zones, identified by the different colors here. So we interacted not only with the teammates, forklift drivers, transfer cars, all these things had to be taken into account. So we divided up into zones so that the crane could safely operate depending on what the condition was. You see the cooling yard zone, the larger red zone, that's where the majority of the coils are stored for transfer down to the far end, and the light pink color for the pickle tube transfer car zone. So long crane moves could be if depending on if say we had rail, we could even re-rail cars in from the center of our coil field zone. You see the railroad tracks there. So just depending on what the type of conditions were, we had to account for that with our safety. So here in this slide, I just have a picture of a gate. We selected the gate system. You want to make sure you accommodate what the conditions are going to be, how dusty, how much water, those type things. Maybe your plant has a certain color push button sequence or light sequence for the gates. These are all things to talk about in your discussions with other teammates. Now this one's a magnetically latched multifunction gate box. It's connected over a Profinet directly into our ground-based safety system. So it made it convenient for one box, one terminal for our gates. Here's an example of one of our entry stations. Steve mentioned earlier. This communicates with our ground safety PLC to move in and out of the requested zone. We have a lockable disconnect, so once you enter go through the safety sequence, the teammate will then operate the disconnect, hang a lock as part of our documented procedure that we've developed at our plant. So that everyone is aware of how to enter a zone safely. And once they leave that zone, they remove their lock, reposition this disconnect, and reset the zone so the crane knows that all personnel are cleared. The crane can go back and travel in that area. There are other precautions to each zone. We have photo eyes and a variety of other safety devices that also interact with these controllers. Also, as mentioned, due to the distance, we had several remote IOs to accommodate all this ground safety. It's communicated using a variety of Stalin's 200 series switches connected over fiber. And then eventually, this has allowed us to have a remote point IO all over the ground and have quick communication back to the safety PLC and then onto the crane. We have an industrial wireless system. We chose to use 802.11a production-based. We are using Siemens. There's several brands out there, but that's a product we end up using. And connects to the LAN directly through a PN coupler. So we go from our ground safety to our wireless to a PN coupler. And one of the things we really learned about with the wireless is IT awareness. Of course, I'm sure your IT departments will be involved in a new wireless system. But one thing, we had a lot of mobile equipment. So we want to make sure that the mobile equipment didn't interfere with the crane. And maybe if you're a larger company, the IT may use a wireless LAN controller that manages what channel the different access points are running on. And so when you have a wireless system inside, you don't want that channel, you don't want to end up being on the same channel for your communication. So we had to go through some learning curves as far as how to identify what channels we're going to let the crane system run on and make sure that we didn't have any overlapping. We did have several meetings of all this, and we're also using a 5 gigahertz band, which most of our vehicles are all using 2.4, so we had separation there, but we took it one step further to even identify what channels we were going to use, so we made sure the communication went through safe as possible and seamlessly. And a wireless survey. This is an example of one of the wireless surveys we did. And we talked about optimization of our hot mill. This isn't a new extension. Before we had our saddles in place, we actually used to have the coil just right down the middle of the building and being handled by fork trucks. And obviously we weren't really optimizing coil storage then. But this was an example of the survey. We've learned a few things from it, and it's certainly something you need to consider before implementing any type of a wireless project with your crane.
So the next step in this project was the Coil management system. And this thing was really the brains behind the interface between the cranes, Nucor, the ground safety system. This was a custom engineered, forward-looking Coil management system built on a .NET platform. Like I said, it interfaces on level 2 for new coil information that's coming. Anytime there's a burst of a coil, the system is made aware of it. It tells us walking beam locations. It handles the transport order information and also is the inventory database for the entire hot mill cooling yard. It interfaces to Nucor's level 2 system for the picker line, so that we can picker line orders in and get all the coil states for that, ready to send them over. And once again, it also interfaces to the overhead crane for transport order execution and for zone statuses.
Some of the things that we were looking to do, we wanted to be able to track the location of all the coils in the yard, as well as coil information. Be able to access that information easily, like the size of the coil, what the ID number is, where it was going. Also, with this management system, it allows us to execute operator inter transport order. We have an example of one of the screens here, and you actually could include all pictures, but you can even it's got a drop-down menu where you can select if you want to create a new transport order for a coil that's already in the cooling yard. And then notes. Who doesn't like notes, right? We want to encourage operators to make notes if there's a specific point on that coil or handling instructions, or maybe there's issues with that coil when it's produced. They can include different notes on that screen, and those are kept over the life of that coil as it's being handled. Also, we have the ability to enable or disable special functions. We have several different functions that we've kind of created over time, and those are all things through lessons learned of different capabilities that need to be adjusted with the crane, such as one of the ones we have listed there is a defrag. just like computer hard drive packing into space. Well, same thing with the crane optimization. We're going out one end of the hot mill extension, and so we pack the coil as close as possible to allow quick loading of that transfer car. So we want to be able to turn that all on and off for testing or other occasions that may come up. Extra large coil handling, that was an interesting topic too. We needed to be able to handle a variety of different sizes. Some customers, the order books started getting where they wanted to create bigger coil. Customers wanted to buy more at a time, so this was something that we had to adjust our thinking with and overcome some situations with saddle and cooling yard optimization. And then saddle X and Y position adjustment. We could do this all through the coil yard management system. Maybe we needed to adjust the saddle, or it was fabricated and we needed to tweak it in order to have a fine positioning of that saddle for better coil handling. Here's just an overview screen. On this overview screen, you can get some quick status of your zones, which ones are available, which ones are not available to the crane. We could learn some coil information, such as which coils are extra large coils, which ones need extra met testing, which ones are wide coils. Wide coils are something you can't put two wide coils next to each other, or you won't be able to get the coil grabs in. So all these things are taken into account, and through the screen you get a quick snapshot of where your coils are located. You see our transfer cars at the far right. That's where the coils exit out, which ones have already been loaded on the transfer car, system status, communication with the crane, all those type of things, as well as access to other features of the crane, including semi-auto operation of the crane, as well as coil retrieval, inventory management. All these things can be accessed through the coil yard management system.
So one of the interesting things that we get out of that coil yard management system are the monthly reports generated at the end of each month, broken down by day. It gives you a quick glance of how many coils were produced, how far the bridge trolley traveled. It also tells you like how and where coils were picked up. Were they picked up from the walking beam? Were they picked up from the dirt? Like if you do a semi-auto kind of move, gives you the total number of transport orders. The graph that you're seeing here is like the overview for the entire month, and that tells you how many coils were, or how many transport orders were executed on that day. And you can see some of them are in the greater 400s. So I mean, there's a lot of coils here. This is an example of a pay breakdown. It's broken down hour by hour, and the different colors on this will tell you, like based on source destination, where you're picking up from. You know, if you're grabbing something from the walking beam, if you're grabbing something from the coil yard, you can get a kind of an idea of where the crane is doing all this work for that day. The bottom graph shows you what destination it's going to. You know, is it being delivered to pick line 1? Is it being delivered to pick line 2? So on and so forth. So this kind of gives you a quick overview of, you know, what was the crane doing that day. You know, is it primarily focused on walking beam stuff? You know, primarily sending out pick line 2. And once again, this tells you the total distance traveled with the log rating. Those numbers are fairly staggering, and we'll get into all that in a little bit. Then finally, the next topic, one of the last things that we do is put an industrial data collection system on. And really, this thing has been key for trying to paint a picture when some kind of event happens. You know, the crane went to some location, that's where it's thinking. You know, we're able to get all that information, try to figure out what went on, and you know, situations like that, or coil information that was sent to us, that being out of the battle, those kind of things. Really, the detective work that kind of comes in and figuring out what happened. This really played a huge role in that. It records and stores all physical I/O, as well as anything that we programmed in from the CFC charts and ladder information as well. The data that's collected was automatically backed up to a network server that was on the ground, so we didn't have to worry about losing any information, you know, having grading systems gone down.
We also included a couple of pictures from some of our camera views on the crane. As we mentioned, this has been 6 years, and as probably many of you know, there have been so many advances in technology and camera technology. Several have been tried over time. We started out originally like the idea of pan tilt zoom cameras, more information or or more technology came out with anti-vibration cameras. So really technology that improved and has really assisted this project tremendously. As well as with this, we have DVR servers on the crane. We also created a new separate wireless network that allowed access to a video stream without interrupting data stream, giving them two separate paths of communication. So that's really assisted this data collection system, is going back and also seeing it, tying it in with video. Outcome. Love this picture. I'm going to say it. Full coil yard here. So the single crane has the ability to handle hot mill production, pickle line batch orders, transfer car loading, delivery to saddles for external storage, for handling by the forklifts. It's led to reduced overall number of coils handled by the forklifts. If you have forklift operators at your site, oftentimes things can happen with forklifts. Whether maybe the coil gets turned upside down, or going too fast for conditions, or running over railroad tracks too quickly. Things can happen. Well, this certainly has helped that. And with that, minimizing the coils handled by forklifts, it also reduces our diesel fuel consumption. Tracking coils produced without using dedicated manpower to do so. It also allows for better scheduling capability. One of the great things that having this bay fully managed by the crane has allowed us to do. And then maintenance costs. So the crane is not being ran by an operator, so they're operators that optimize the speed with regard to acceleration and deceleration. And that has helped as far as the crane operation goes.
So these graphs here, this really paints a picture of, the kind of throughput that this crane goes with, what it handles. Just in the year 2017 alone, this crane handled, 46,000 coils, delivered almost 19,500 coils to pickle line 1, 13,000 coils to pickle line 2, and anything going to pickle line 2 has to be handled twice. 14,000 coils to external storage. All of this, with the addition of semi-auto moves and defrag moves that this crane does total, 102,000 transport orders executed for an estimated 2.88 million tons moved in 2017. To put a little more numbers to that, in 2017 alone, bridge traveled 6,000 miles. So yeah, you wouldn't believe it until you saw the first charts that we put out. That's equivalent distance from New York to LA and back again. The trolley, 1,300 miles. That's the distance from Oregon to Nucor and back. So, those numbers aren't astonishing then. Yeah, too bad they are. 46,000 coils handled by the crane in 2018. Deliveries, 23,000 pickle line 1, 12,000 pickle line 2, 13,400 external storage. 2018, 121,000 total transport orders for an estimated 3.41 million tons moved. And total bridge travel 6,900 miles. That's an increase of 16% from the previous year. Trolley travel 1,600 miles. That's a 23% increase. So you can see this thing is really running. 24/7, 365. Obviously, lessons learned. There's things you go out there, you expect this thing to work, it's perfect. You go and research and you get an issue like this. Operator training is really key, and it cannot be stressed enough. The operators need to understand that their actions have consequences. So when you're dealing with an automated system and you have somebody that's trying to manually pick and place coils, you end up with a situation like this where the bottom coil was placed by an operator without updating the coil yard management system. Separately, another operator had disabled the coil detection system. And as a result, you can look at it one of two ways. A double stack, or it's just an instantaneous increase in capacity. So, we love that picture. Miraculously, it didn't fall off there. It was quite the chore to get it off without it falling, but this is one of those examples that the operators need to understand what they do, and that does have consequences.
Yes, training an operator is never ending. That's an ongoing, continual process. Some other lessons we learned was regarding coil packaging. And this can certainly vary by who's operating the mill at the time or what type of situation they have going on. But most coils produced do have smooth sidewalls, but unfortunately sometimes there are cases that do not. So we've had to really undergo some training with what can the crane safely handle. Now this is kind of an exaggerated picture of what telescoping of a coil looks like, but obviously the point on the left side is going to be a far weaker point to pick up as compared to the other side. So we've had to come up with a procedure, how to identify what the crane can handle. And this is something we've had to learn and adapt over this 6 years. And coil banding. As was mentioned, most of our coils go to the pickle to transfer area, and those bands are then cut off. And so we're looking at ways maybe we could reduce some costs, save some bands. We found out that different coils, as was mentioned, these coils come off the mill hot, and as they cool down, things change as far as how the coil is. I have a picture here showing the inside of a coil. So we had to do some evaluation with as far as what the gauge material was. We made some changes as far as our banding. More banding is required, certain gauges. But it has optimized what our banding needs were, and it has saved some money as far as our banding goes. So that's something we need to consider as well.
One of the big issues that we have that this picture depicts is that the eye of the coil with that innermost wrap. Generally the crane expects that this coil is just kind of a solid object. But when that last wrap falls down in, we're not able to get the coil wraps in because it interferes with that. That's another reason that the banding thing was really important, because we need to make sure that thing is, that thing is all held tight together and we don't have a bunch of loose wraps.
Then rack design. You don't really think too terribly much about when your coil racks, how the coils are considered. So we went with the traditional rack design at first that was being used with the forklifts. And we found out that due to the pace of the crane, due to the heavily areas that the coils were set down, transition areas, you can see the pipes were really starting to wear down. So we came up with a new design, a thicker wall pipe, internal gussets for our areas that are highly utilized by the crane. And when we have this problem, as mentioned in the notes there, when it comes time to pick that coil back up, it makes it difficult for the crane if the crane isn't sitting at the same height that we expect it to be, or it's not sitting level. This resulted in issues with the crane pickup. So it was something that was unexpected, and we certainly worked through. And then use case scenarios. Mentioned there are knowledge worth of use case scenarios were thought about when this project was being implemented. And one of the ones that we did miss at the beginning was what happens when the wireless goes away. Well, when wireless goes away, it's a safety concern, so we want the crane to stop. And then how do we recover from that? So we went back and we troubleshooted the scenarios, and we ended up with a variety of visual indications, program code changes, procedures. But again, the point here is meet together as a team, do the best you can, but there's going to be some scenarios that you're going to have to work through, and this was an example of one of them that came up. And then maintenance. Always needs of maintenance, especially as maintenance technicians, engineers, you're always looking to make maintenance as easy as possible with design equipment. But for example, for coil grabs, we came up with additional remote ports for greasing, lubrication. The mount the crane was being used changed over time. So we even consulted with lubrication technical advisors for different lubricants so that we could try to increase the life of the grabs and due to the temperatures, right? We mentioned 1600 degree coil temperatures as well. And then wear items such as foot pads, toe strikers, We're also evaluating so we can make them replaceable due to the high amount of coils that were being handled by the crane.
And finally, one of the last things, or the last thing that we're talking about, assumptions or misunderstanding of how some of the equipment operates. We all make assumptions, it happens. One of the biggest ones that kind of came up was, unfortunately, easy to fix was when coils would arrive on the locking beam for the crane to pick up, we, as in Oregon, assumed that they would land in generally the same spot every time. What we came to learn once we got on site was that those coils could be shifted by 6 inches one way or the other, and the crane needed to be able to handle that. And without the appropriate, tracking of coil position or vision systems or what have you, our method to attack this was to approach the locking beam with the coil grab who's full open position, and use the side flappers as kind of a guide to pick the coil up. So if you would go down and grab the coil and only hit one flapper, you would end up using the bridge of traveling to try to find the center of that coil to the point where you got both flappers engaged. And along with that, we threw in some additional protections to make sure we didn't have issues with like bridge over travel or situations like that. So that pretty much wraps up all the lessons learned. I'm sure we're gonna have some questions, or at least hope we have some questions.
There will be some time also at the end of the day for some additional questions. We have time to take one or two now. Anybody? Back in the back row? John? He's John Novak from Prime Metals. See, I saved him that.
Yes, I have a question with the, I guess, regards to the heat of the coil and the fine electronics, like the eye of the coil or the detection eye. Does that affect how it performs? Sometimes you have the heat giving off, and then you have this, I guess, eye coming down to the center of the coil to try to detect. You have the center of the coil, does the heat kind of throw that off at all? Or?
Surprisingly, no. The electronics that we put in the legs themselves, I think they're going to be any issue. Sorry.
Presentations like that. It's
Can you hear me?
okay.
No, we haven't had any issues with electronics, and really that's kind of been a surprise to both of us. And the amount of time we've spent on this thing, 6 years now, we haven't had a single failure of any piece of electronics that's between the legs. We do actually monitor leg temperature as well, and with this thing handling 1,500 degree coils all day long, we're likely to see in the heat and the steel itself more than 250, 300 degrees. But the long and short answer, we actually have not had electronic problems.
Thank you.
Let's give a round of applause for our presenter.